Jupiter doesn't just dominate the solar system with size. It also radiates death. Its enormous magnetic field traps charged particles from the solar wind, creating a radiation belt thousands of times more intense than Earth's Van Allen belts. If you were floating near Jupiter, unprotected, you'd receive a lethal dose of radiation in under a day. Now, imagine Earth developing that same monstrous field. Magnetic fields are partly determined by a planet's size, rotation speed, and core composition. A Jupiter-sized Earth, with a faster spin and molten iron core, would likely generate a magnetosphere far larger than our current one, stretching for millions of kilometers into space. But this wouldn't be a shield, it would be a trap. Solar particles would get caught, spiral, accelerate, and bombard the upper atmosphere. Instead of protection, we'd be surrounded by a giant radioactive halo. Satellites would fry. Even our most hardened space tech wouldn't survive long in that environment. GPS systems, weather satellites, communications networks, all rendered useless within days or weeks. Space agencies would need to build radiation-hardened spacecraft, protected with lead, magnetic shielding, or even active deflection fields. Human missions to orbit? Almost impossible, unless new radiation-blocking tech is invented. We'd become prisoners on our own world. The increased radiation wouldn't stay in orbit. As charged particles slam into our atmosphere, they would create hyperauroras, dazzling lights stretching far beyond the poles, visible even from the equator. But they come at a price. These particles would strip away the ozone layer, increasing ultraviolet radiation at the surface. Cancers, mutations, and ecological collapse could follow. Clouds might glow at night. Lightning storms might become electrified with gamma bursts. And rain? Potentially laced with radioactive isotopes. Life would need to evolve or perish. Surface species would struggle. Plants exposed to UV spikes might wither. Animals could suffer mass extinctions. Human skin cancers would skyrocket. But underground life, or deep ocean species, they might thrive. Humanity might retreat into bunkers, domed cities, or subterranean arcologies. Civilization would go underground, literally. We might even bioengineer humans resistant to radiation, with reflective skin, rapid DNA repair, or even synthetic blood. To survive in this radiation hellscape, we'd need a new kind of infrastructure. Shielded orbital rings to reflect or absorb particles. High-altitude energy filters using electromagnetism. Global early warning systems for solar storms. Entire industries would rise, focused not on exploration, but on defense from our own planet's field. And perhaps we'd start building space stations farther from Earth's deadly grasp. This version of Earth is still beautiful, majestic even, but dangerous beyond anything we know. And it might change how we view the universe. No longer the gentle blue marble in space, Earth becomes a reminder that scale is power, but also peril. That what protects can also destroy. And that survival isn't just about technology. It's about adapting to truths beyond our control.